This video is sponsored by PV Case. Last year I bought this 13-foot fiberglass boat that was in terrible condition and then spent way too much time and money restoring it. After that I built dual electric outboards out of some 2x4s and e-foil motors. Next came some giant solar panels that fold out on the sides. This allowed me to drive all day. But there's no point in having a boat with unlimited range if you don't use it. So in this video I'm going to see how far I can go on Lake Roosevelt in eastern Washington state. In theory, I could make it 140 miles all the way up to the Canadian border, so I folded up the solar panels, took the motors off so that they wouldn't get damaged on the road, and headed out east on I-90. 3 hours later, I arrived at the lake and started preparing the boat. Once the motors were mounted and the solar panels unfolded, I loaded up all my gear and put the boat in the water. I had enough food and supplies to last me around a week, but I also wasn't sure if the boat or my patience would hold up for that long. In addition to just surviving, I'm also going to be testing out some new propeller designs on this trip to see if they can make my boat any more efficient.
Here we go. Let the mission begin. Goodbye, land. Just gonna get out into open water, start our course, and then get this boat organized. Day one at Lake Roosevelt. We're finally here. I was gonna launch yesterday, but there were high winds, so I waited until today. And there were still high winds today, but now it kind of died down enough in the later evening as to where I was able to get the boat out on the water, and we're just cruising downwind. Even with the sun this low in the sky, I'm still getting like 200 watts of power from the solar panels right now, so that's pretty good. I'm just kind of surfing these wind waves. We're cruising at about 300 watts. Slow and steady, that's how you win the solar boat race. We're just surfing the wind waves. It's nice out here. So yesterday Sebastian made me a safety feature, which is a dead man switch. Basically this is a little ESP32 Arduino thing that goes in there with the autopilot, and then I keep this tile in my pocket and it's connected to Bluetooth. So when I fall in the water and this gets too far away from that receiver, the boat will shut off. But right now there are some bugs. The boat's shutting off every like 10 minutes or so, so I'm having to go into Mission Planner here and make some changes. The sun's getting real close to going behind the hillside, and I just got our waypoint mission set up. So now we are autonomously driving. We got a long ways to go. This is a big one. Pretty good. Riding the swell. I bought this marine radio just in case I shipwreck, and so far all it's given me is country music. Just gorgeous. We're using up about 500 watts to do 2 meters per second. So the sun has set, but the batteries are still just about full. So I'm gonna keep going until they get to around 50%, or I'm just too tired to keep going. And at that point, I'll find a place to drop anchor and go to sleep. There's a lot of little coves along the edge of this lake, so hopefully I'll be able to find a nice calm place to drop anchor. It's about 9 p.m. and the wind is picking up a bit. I've got my nav lights going. Now we have a tailwind, and we're drawing about, let's see, 300 watts to go 2 meters per second. That's pretty good. But the waves are also building a bit. I lifted the edge of this solar panel up so that we don't catch it on any waves. I should probably do the same to this one. Wow, this camera is so much better than my eyeballs in low light. I have to look through the camera to see anything out there. There's a bunch of flashing buoys out here, so I'm gonna go see what they say. Fisheries research. Okay, well, I don't know what that means, but all right. Man, I sure am glad I have this satellite imagery data to reference, because I have no idea where I am, or I would have no idea where I am. Just cruising along, hoping I don't get eaten by a swamp monster. I think I'll anchor right back in here. Whoa, flock of birds. Wow, pretty shallow right here. Okay, in goes the anchor. Bats flying around, eating the bugs. Majestic, all is well. Time to go to sleep. Here's my bed. I even brought a full-size pillow. That's right, we're luxury camping. Oh yeah, there it comes.
Okay, let's pause right here for a sec. If you've been following my video series about this boat, then you know I've been having vibration issues. At first, I thought the propeller blades were just out of balance, but I balanced them to the point where they were perfectly smooth out of the water, but that didn't matter once they were back in the water. I also tried extending the mast down past the bottom of the motor and lots of different propeller designs, and nothing worked. But then I figured it out. Here's a cross-section of the outboard mast. The problem is, it's too fat. So I designed some 3D printable attachments that extend it and make it more streamlined. So that's what you see here. And they made a big difference. Still not perfect, but much better than before. Now back to Lake Roosevelt.
I'm wanting to get moving as soon as possible. Seize the day. There we go. Whoa, look at that, there's a ferry. Looks like there's a campground and maybe another boat ramp over there. Back out on the water, making progress once again. Cruising at 2 meters per second, 500 watts. That must be the ferry terminal right there. Dang, it's not even 7 a.m. yet and we already have some pretty big wind waves building. I mean, they're not that big, but bigger than what I would expect for 6:45. It sure is pretty out here. I just pulled up onto the beach here because one of my propellers seemed to be vibrating a little bit more than the other. So I'm gonna swap it out and see if it gets any better. These are resin printed on the Form 3 Plus. These are B series type propellers. I generated them with some online generator that I found, and then I printed them in 3 parts. So they're 3 different 3D printed pieces all bolted together. But it's this one that's vibrating more for some reason. So I'm gonna try and swap it out with this one. This has a thinner cord, so in theory it should be a little bit more efficient. So we'll see if this vibrates less. Vibrations just scare me because it fatigues all the joints and the other 3D printed parts and stuff like that. So I'm trying to reduce vibration as much as possible. There we go, got the new prop installed. It's a different size than the other one, but that shouldn't matter because the motor drivers are in torque control mode. So they should produce roughly the same amount of thrust. We're back underway and it seems to be vibrating a little less, that's good. Not sure why this one was vibrating more. I could have sworn it was running smooth the other day. A little rock marker right there. Okay, on we go. I would imagine most of those are like summer cabins. I don't know that people would love to live out here in the winter. What in carnation? Looks like someone's living right there or something. Nice place to live though. A bunch of little coves over here. This would be good for camping. I'm doing some flight controller tuning right now. It's clear the steering angle is overshooting the set point. It works fine in calm water, but in these waves, you get a lot of overshoot. So I think the controller's a little overtuned here. So let's talk about our plan. This is the whole lake right here. It's really long and narrow because technically it's the Columbia River. So I started right here and now I'm right here. So I've gone that far. Now my kind of initial hope was to make it all the way up towards the Canadian border, but that's pretty far away. So I'm thinking once I get to this fork right here, I'll make the decision to either continue up towards Canada or maybe I'll just go up this narrower section and go see what there is to see up until I hit this dam right here. So we'll see how I'm feeling at that point. Ah, here's an interesting little cabin city. It's pretty remote, not a lot else out here. There haven't been very many people either, although there's a boat. It's the first one I've seen all day, other than the ferry. And the thing is, the more time I spend going up the lake, then the more time it's gonna take to come back. So the trip duration grows by a lot the further up I go. So I'm just kind of trying to figure out what my plan is. But right now the water's gotten more calm. I think we're wind sheltered by those rocks over there. So it's nice and flat and we're just putting along. Last night I drove until like 10:30 p.m. So I was using battery power only. And the batteries were only like, I don't know, at 75%, so I could have kept going for a lot longer. So we'll see what the battery state of charge is after driving all day with the solar panels making power. They should be able to make more power than I use to cruise at like 2 meters a second. So we should have a surplus of energy by the time nightfall comes, and then I can drive into the night a little bit again. We'll see. Wow, look at that cliff. There's a whole bunch of them. Wow, I can't believe people live out here. It's so remote. There's a houseboat camp out. Looks fun. It's now 9 a.m. and we're getting about 600 watts from the solar panels, so I increased our cruise speed to 2.2 meters per second. So now we're burning about 600 watts on the motors, and then at noon I expect to get about 1,000 watts from the panels, so then we'll start charging up the batteries again. Now I've got a third solar panel charging this big battery bank because I'm using this to charge all the cameras and the computer. For breakfast this morning, I have cookies. Don't worry, they're healthy cookies.
Okay, so it seems my flight controller just died. Ooh, that doesn't look good. Ugh, there's some sort of a power issue somewhere. The flight controller was getting power from the VESCs, and I plugged this power meter back in, so that's also giving the flight controller 5 volts now, and it seems to boot back up. Hopefully it's happy. Let's see if I can arm it. Okay, I have steering, that's good. And I have motors. Woohoo! We're back! That was weird. Seems like there's some sort of an issue with the VESC 5-volt supply. Oh, that's an official campsite. Looks like. Oh, they have a slide. Sick. The water is just glass right now. It's so nice. I've got the world's most uncomfortable camping chair here, and it has shade. Hopefully the panels don't hit instead of going through a boat's wake. There's another houseboat over there. Looks nice. Got some jet ski hooligans up there doing turns and such. I hope this wake doesn't hit my solar panels. Oh no. Oh, fuck. Oh, shit. Damn, I shouldn't have had them in the flat position like that. Nice soft beach. Now for a word about the sponsor of this project, PV Case. If you're involved in the solar industry, you know how difficult it can be to plan construction of a large-scale solar plant. You have to consider all sorts of things like topography, geography, shading, mechanical design. Luckily, to help with that challenge, there's PV Case. PV Case is a next-generation AutoCAD-based PV software that allows users to simulate the physical locations of a solar plant, incorporating 3D topographical data of the surroundings. PV Case is the ideal choice for companies undertaking large commercial and industrial projects, as well as utility-scale plants. The software's intuitive workflows and streamlined processes help reduce the learning curve and improve productivity. By offering features for prototyping, electrical design, stringing, shading analysis, terrain analysis, and automatic generation of construction documentation, PV Case enables engineers and designers to take a project from its initial stages all the way to the procurement phase. This end-to-end approach can help streamline workflows, save time, and reduce errors by eliminating the need to switch between different tools or software platforms. Their ground mount solar plant feature offers flexible 3D modeling in complex terrain, resulting in shade-free table placement. It also has piling and collision analysis for motion-controlled panels, and automated 3D cable routing that even accounts for topographical variance. Their roof mount solar array feature offers rapid 3D building preparation, shading calculation, and semi-automated electrical design features, all making it much easier to plan and procure solar power systems. Click on the link in the description to learn more about this awesome software. Now back to the video. Oh, not so good. See if I can bend this back at all. Not great. Oh no, it just bent here now. Oh no, it's just buckling more. The other side's bent too, damn. Well, these have got to come up. Now I've got a crippled boat. Dang. Okay, we must keep going. What incarnation is that thing? I was never much of a tubing fan. Whoa, check it out, there's horses here. There's a fork in the river. The Columbia goes that way, and the Spokane River goes that way. So it's about high noon. The solar panels are making 850 watts. We're cruising at about 700 watts, so we're charging the batteries slowly. I'm feeling kind of discouraged after the solar panel got damaged there. So I think what I'm gonna do is go up the Spokane River instead of the Columbia River or Lake Roosevelt. You'll see that there's a split ahead of me, and basically I'm just gonna go right instead of left, and the river will narrow, and then I'll see how far I can make it. There's a dam up there quite a ways. It gets really narrow up here too, so that'll be interesting to see if I can make it. There might be too much flow for me to even go upriver. And also, if I had like 100% confidence in these motors, then I would be down for a much longer trip. But I mean, after all, they are held together with PLA 3D printed parts and a 2x4. I mean, they're not like that robust. I don't think they'll break, but it's just like, you know, I don't have 100% confidence, and I really don't want to get stranded like 130 miles away from my car. Wow, this looks like it's a pretty big campground in Marina. Look at all those houseboats, holy crap. But check out this bridge. Wow, there's a little boat. Is that a Boston whaler? Just like mine? This map has mile markers on it that show the distance from the Coulee Dam right here. So I am right, let's see, where am I? I'm right here, so I've gone 40 miles so far. flight controller does not seem happy. Well, maybe it's overheating. I'm gonna leave the lid ajar. I'm getting just about 900 watts from solar, and now I need to start thinking about lunch. I've not eaten enough today. Yet another nice place to camp. Well, the EF Delta stopped charging from its solar panel. It must be overheating or something, I'm not sure. What do I want? Granola? No thanks. I'll go for a chicken fried rice. That sounds pretty good. Oh yeah, chicken fried rice coming right up. I've got my liquid cooling turned on since the motor drives are baking in the hot sun. You can see the water coming out back there. Wow, yeah, it actually keeps them really cool. That's surprising. As these speedboats are driving by me, I've kind of come to realize that I'm like the hobo of the lake. Oh, big waves. Oh, yeah. Still too hot. Oh, there's a big patch of seaweed up ahead. Gotta do an emergency evasive maneuver. Whoa, they got a teepee over there. We're cruising downwind now. Check this out, I was looking at Google Maps and there's a uranium mine somewhere up there. It's too hot out here. That felt good. Let's go see how our motors are holding up. Looking good. I'm getting pretty far up the Spokane River now. Whoa, that's a legit boat ramp. I didn't expect to find one of those way back in here. That's like a tiny house city over there. These people are checking me out. Oh no, they're gonna swamp me with their wake. That looks like a pump house. I think the uranium mine was up there somewhere. What a place. Beautiful day, that's for sure. Here's another pump house. This one sounds like it's running. Here's how I'm getting drinking water. Just filtering water from the lake. We are now at this very narrow section right here. And we started 24 hours ago right here. That cow's going for a swim. Should I go up there and write subscribe to RC Test Flight? Probably not, but you should. That person's got some nice boats. I think this might be an Indian reservation. I'm not entirely sure. Wow, it is so glassy. That's awesome. Look at that house just nestled into the rocks. Here's a little hack. This radio that I'm using to control the boat is actually the European version, which means the transmit power is limited at 25 milliwatts. That would be bad if you're trying to fly a drone or a plane at far distances, but I'm not using it at far distances, so 25 milliwatts is just fine. And since it draws so little power, the battery will last a really long time, so it'll easily go for like 2 days without charging. So this is interesting. In the imagery data in Mission Planner, there's a big sandbar right here, and the waypoint mission ends at that point right there. But in real life, there's no sandbar there, so the lake level must be pretty high right now. Although I do see some bushes sticking up out of the water, so that must be it. Oh, and the motor's just stopped. That's the last waypoint in the mission. It is so incredibly quiet out here. There's just no noise, except for those stupid geese over there. Well, this is pretty majestic. I'm glad I came out here, but I also don't really feel the need to go very much further. The dam that's at the end of this finger of the lake is about another 10 miles ahead. And you know what? I bet that 10 miles will look a lot like this. Probably not a lot different. And like, I can just look up pictures of the dam on Google when I get home. If I turn around now, I can find a nice place to camp tonight along this section here and probably be home by Friday if nothing breaks. And that sounds pretty appealing. Away we go! Into the distance we go. It feels really good to finally be going home. And since the seas are calm and the journey is long, I'm doing some editing. Ironically, about videos of this boat. Look at how glassy it is. That is amazing. Earlier today I was feeling pretty over it, to be honest, but when it's nice and calm like this, we're just cruising along slow and steady, there's a pretty sunset, it's not bad. I'm enjoying this. So the motors are pulling about 350 watts, and right now at this non-optimal sun angle, the solar panels are only making about 100 watts. But that's okay, we're just gonna run on battery power until it's time to go to sleep.
I'm trying to edit, but I just keep getting distracted by how glassy and beautiful this water is. Now their wake is gonna knock over my jet boil. Oh no. Wow, look at the convergence of that wake. It's making a rooster tail between the two boats. Tonight we have beef stew. Oh, yum, yum, yum. Looks like there was a big landslide at some point right there. That must have formed a tsunami that crashed into the shore over here. Huh, I wonder. Sky's looking nice and pretty tonight. Oh, oh, beef stew. Oh, how I do love you. Too hot. Oh, I found a campsite on the imagery data, but it's still probably another mile or two down the way, so I'll probably not get there until it's dark. Seems like a nice little cove here, but there seems to be wind just funneling down this canyon. Maybe I'll move one cove over and see if it's any better. This looks like a fine place to be my home. I'll just go right in there. I've got one anchor off the bow, but I'm gonna put a second off the stern because I don't trust the one anchor with these cliffs around.
It's 4:40 in the morning and I feel ready to start moving again.
More cookies for breakfast. I can see the bridge in the distance. Amazing. After I pass under that, I only have a full day of driving left. This whole slow speed, self-guided GPS boat thing is pretty cool because, like, how many other vehicles are there out there where you can just turn it on, start going, and then just chill, you know? I have to make sure I'm not gonna hit anything once every few minutes, but other than that, you just hang out. Look at that, it's a bald eagle. Amazing. Someone was doing the hill climb challenge. Getting closer. Oh no, I think my waypoint mission is gonna take me right into this buoy. Yeah, it definitely is. Okay, manual override. Can't get me this time, buoy. And we'll go back into auto mode. Just cruising along as usual. I feel like I've gotten pretty lucky with wind direction so far on this trip. We're going downwind once again. I'm sailing! Hey, we're back to the missile silo. I raised one panel up for a better solar angle. We're doing about 470 solar watts right now, and our motor's pulling about 350 watts, so we're slowly charging. We're just coming around to the other side of this bend here, and I'm hoping this side will be wind sheltered, because the wind was coming from this way on the other side, so this way the mountain will be blocking it. It's almost 10 a.m. and it's still super glassy in this canyon. That's pretty nice. I took the boat out of autonomous mode so that I can reroute over to this beach. I'm gonna switch propellers. Look at these bad boys. Oh yeah, we're gonna try them out. These are gorgeous. It's pretty windy, so I just anchored the boat to the shore so it doesn't blow away. I'm gonna swap the props now. Look at those things. They're beautiful, but they're useless if they don't work, so let's test them out.
Let's pause right here so that I can explain these propellers. A few months ago, I made a video all about testing this toroidal propeller design versus standard propellers, and they were terrible. By blowing bubbles into the prop, I could visualize the flow, and this gave me some ideas on why they might not be working. First of all, the pitch is too steep. Bubbles seem to be clinging to the underside of the blades, indicating that they are stalled. Second, the root of the propeller is swept back at too steep of an angle. I thought this because it seemed that the bubbles are mostly sticking to the root. And the flow visualization from AirShaper seems to show that there's a lot of span-wise flow here. Also, normal boat propellers seem to have a neutral or even forward swept blade angle at the root. Also, I discovered that the Sharrow Marine patent for toroidal propellers shows that the outside of the loop needs to have a positive angle of attack so that it actually sucks water inwards. Mine did have this positive angle, although it was only 3 degrees. Lastly, my blade profile shape was crap. So, I created this new design to address all these issues. I increased the angle at the center of the toroidal loop to a whopping 9 degrees, got rid of as much of the root sweep as I could, lowered the angle of attack a bit, and improved the airfoil profile. After that, I 3D printed them in 3 sections on the Form 3 Plus, tapped some holes, installed the center hub with some big long M3 screws, Added a plate to the back to hold them all together, and another plate in the front, and this is what we ended up with.
Beautiful. Well, they spin, so that's a good start. Although the wind kind of screwed me over for this test, because the whole way here I was paying close attention to the power draw of the motors for going at about 1.6 meters per second. And now the wind picked up, so when I'm going downwind on my way, the current draw, or the power draw, will be less. I'll keep these on for a while and try and get a feel for them in different wind conditions. So first impression is that they're pretty smooth. Definitely a bit less vibration than the other propellers. But when we have a look at the power consumption, you'll see that it's costing us 700 watts to do just 1.6 meters per second. That's a lot worse than the other propellers. And we're going downwind. Damn, I really thought I had learned some stuff from my last toroidal propeller design, and I thought that these would be better, but I guess not.
So if I had to guess why they performed so poorly, I'd say that the 9-degree tip angle was probably way too much. I don't think the blade angle of attack was too steep. If we measure it at the root, it's only about 27 degrees for the top blade and 40 degrees for the bottom blade. In comparison, the B-series prop that's been working great is 35 degrees, so we're kind of pretty close to that. I do think the bottom blade should have a steeper angle of attack than the top blade, since you want the water to accelerate as it passes through the propeller. Hopefully, in a future video, we'll get a chance to blow bubbles through these things and visualize the flow to help figure out what's going on. We're back to the high aspect ratio B-series props.
Efficiency mode, engage. All is well at the moment. The wind is surprisingly calm, and I'm just having a beef stick. Not bad at all. Damn, these thin forged B-series props are slick. Down to cruising at like 300 watts. It's a shame because these things are nice. They're like really dense and heavy. They feel like ceramic almost. I 3D printed them out of the Formlabs rigid 10K resin, and it's really expensive stuff, but it's super rigid and it leaves a really nice surface finish that's super smooth. Oof, 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 oof. This guy's checking me out. They're wondering what the hell this is too. Everyone's like, what the freak is that guy doing? The floor was getting so hot that I had to put down a towel to walk on. Today we're gonna try spaghetti with meat sauce. Woo! These people are following me.
What are you doing?
Boat camping!
Oh, okay. What's powering you?
The sun!
Those are battery operated on the back?
Yeah, they're electric motors.
That is the coolest thing, dude. Good for you.
Thanks. It's noon and the wind has not picked up yet, which is amazing. The weather is a little different today though. We got some cumulus clouds on the horizon. Hopefully they don't block the sun from me. I was trying to edit my YouTube videos, but these tubers keep making waves. Spaghetti's all right. I wouldn't say it's my favorite freeze-dried meal. I've been driving down a super long straight section of the lake for like the past 45 minutes, and there's something just magical about being able to focus on editing and paying attention to where the boat's going, maybe like 0.05% of the time, while we're just banging out miles autonomously. It's pretty great. I'm cruising at 2 meters per second and the wind is still very calm. Just amazing. So much solar! Got the GoPro up there doing a hyperlapse. Does anyone know what makes these weird wind lines in the water? It's like a big snake of calmness that goes all the way to the other side. Moo! Moo! Oh yeah, I can see the bottom. It's nice and clear here. I think I'll go for a swim at this little beach. Oh, I'm gonna chop those up with the propeller. Oh yeah, those weeds definitely got caught. Oh, bye. Sorry to scare you. We are back underway and we're about to round the last corner before we get to the straightaway that leads to the Grand Coulee Dam. So we're getting closer. I'm back to the part of the lake where there's a ferry. You can see it sitting over there at the terminal. Oh, and there it is going across. How did they get a boat that big up here? They must have had to assemble it on this lake. Oh, there's a lot more boat traffic out here than before. Going to investigate. I just got some really weird noise and vibration from the motors, and that's why. Oh no. I had these 3D printed slipstream devices just glued and taped on with just a tiny bit of hot glue and some Gorilla Tape, and it finally gave way. Must have hit the prop. I wonder if the prop's okay. That's the real question. I would be amazed if it's not damaged at all, because this is just resin printed out of Formlab's Gray Pro resin. It totally feels fine. That's amazing. Look at that. It just chewed through that PLA. There's just no wind and it's so quiet. For 1 p.m. it's so calm. This is incredible. It doesn't feel like there's that much more vibration either, so maybe it's just the rear part that makes the difference. This part was on the front. Damn, what a boat. Pretty neat. Huh, there's only 2 cars on there. The solar panels are making 800 watts. And I'm trying to stay out of the sun. Holed up in my little tent here. So I just edited the waypoint mission, so instead of stopping at the campsite, we're gonna go past that all the way to the Coulee Dam. We'll go check that out since I think we have some extra time today. Oh, a cloud just went in front of the sun for the first time. Wow, amazing, I can come out of my hole. Look at that, majestic. Let's see how much power the solar panels are making with the cloud obstructing them. 100 watts. So that goes to show that on a cloudy day, my range would be limited greatly. Oh, sun's back out. There we go. Holy crap, look at that. Whoa, that's a military something or other. Wow. Got some more looky-loos over there. I've been cruising at 1,000 watts for the last hour or so just because I am almost back and I don't need that much capacity left in the batteries. I can see the ramp where I launched the boat up ahead, but I'm gonna keep going past it for about 2.5 more miles until I get to the dam. And then I'll probably camp up there and then pull the boat out and drive home tomorrow morning. The wind has picked up a bit, but luckily there aren't any big wind waves yet. Hopefully none develop. Wow, I see an awful lot of power lines coming into view. That must be where the dam is, right over there. There's a wakeboard boat checking me out. I feel like a freaking mummy right now. That looks like a bridge, not a dam. Maybe those are the spillways? And it's on rails. Oh, it's on a train that dumps it into the water. Whoa, that's awesome. It seems like with this EcoFlow solar panel sitting out all day, this battery only gains like maybe 5% or something. It kind of sucks. It doesn't seem like it generates that much power.
Shout out to Daniel from RC Films, right?
RC Test Flight.
RC Test Flights. I'm David, first time meeting him. Guys, subscribe, like, comment, you know.
Wow, can you imagine living down there and just knowing that the only thing keeping your house from getting hit by a 400-foot wall of water is some concrete? There we go. Well, it's a good thing my batteries are mostly full because that's a big cloud. According to the fish finder, it's 382 feet deep right here. That's pretty impressive. Looks like there's people living up in the hills there. So now I'm gonna cruise over here and then along the shoreline and look for a nice spot to camp before I go back to the boat ramp over there in the morning and go home. You can't do that. Let's see how many solar watts we're getting right now. 24 watts out of the solar panels. And the sun is behind that big cloud. Wow, the sun shined through for just a second and then it disappeared again. Oh, hot. The beef stroganoff is good. Would recommend. Found a nice little cove here. This is where I will sleep. The wind really picked up right when I got in here. Damn. Wow, it's blowing now. This is a tricky anchoring situation because the wind is coming this way, but it's kind of wrapping around this little hill and pushing the boat straight back into that rocky beach. So I tossed one anchor up onto the rocks and used that to pull the boat over. Then I hopped out on the beach, found a better place for the anchor, kind of a little bit in from the point where I unloaded. And then once that anchor was set on the shore, Came over here and took the little anchor and tossed it off the bow and got it hooked on something, you know, out in the deeper end of the bay, and tied that to the front of the boat. So that way the wind will keep blowing the boat offshore and that anchor will hold me. But then if the wind switches, this anchor is grabbing out there, so it'll hopefully prevent me from swinging back into the shore. I can't believe how much the wind picked up right as I got in here. It's crazy. Oh, that's cool looking. Trying to find another bat. I just saw one. Oh, there it is. There it is. Whew, whew. See it? Wow. The moon's out. The wind has calmed down, luckily. When you shine a flashlight into the water, it is insane how much stuff you can see swimming around. There are living things in every square inch of water. I wonder how many of them are stuck in my water filter now. Good morning. It's about 5 a.m. and it's a little breezy, but it's not too bad. I'm gonna go get the time-lapse camera off the beach and then pull in the rear anchor and then scoot forward a little bit and then pull on out of this cove. And then I'll probably go pull the boat out of the water and drive home. I'm still rocking the original Mavic Pro. The sun has risen. I just pulled up the anchor and now we're floating out into the middle of the lake, and I'm gonna get this boat packed up and then head to the dock. When I turned around to the Spokane River and started coming back, I was feeling pretty ready to get off the water. But now I feel like I could do a few more days out here. I'm kind of wishing that I would have kept going all the way to that dam, the additional 7 or 8 miles or whatever it was, and then turned around from there. I think at the time I was just a little sketched out that I was so far away from the trailer and I didn't have super high confidence in the motors, but I'm feeling a lot better now. So maybe next time, if there is a next time, I'll have to go a lot further. We'll see. This trip has definitely been a good learning experience. It's pretty incredible. I went all that way with motor mounts made out of 1/4-inch plywood and 3D printed PLA parts with big cracks in them. And other cracks that I had tried to repair with a 3D printer pen. But I had backups of these parts, so if they actually had broken, I could replace them. This is the town of Grand Coulee. This place looks like it's seen brighter days. Look at that, there's a deer hanging out right there. Wow, that's a pretty tall dam. The water line was right underneath those arches, so that's all lake from there to there. So according to this thing, those are generators and those are generators. And these have 230 kilovolts in them right now. And that is the amazing sand pile. Oh my God, it's gorgeous. There's some water leaking out the top. 200 billion kilowatt hours of electricity each year. Wow, that's crazy.
To put that into perspective, my boat used about 14 kilowatt hours on this whole trip, and that works out to be about 9 miles per kilowatt hour. That means in 1 second, this dam creates enough energy for me to do this whole trip 50 times. Pretty impressive. So I went 58 miles each way, plus a little further to the dam, so I probably did about 125 miles total. Not very impressive considering that people can run that far, but I'd say this was a great little trip to get a feel for what long-range solar boating is like. In the future, it would be fun to try and make it all the way to the Canadian border, but for that I definitely want a faster boat. Need something that is efficient at displacement speeds, whereas this Boston Whaler is pretty inefficient at displacement speeds, since it's just designed to be a planning hull. I was averaging 3.8 miles per hour on this trip, so if I were driving 12 hours per day, it would take me 30 days to go from Seattle to Catalina Island on this boat. Of course, in real life that would be really stupid to try because this boat is not seaworthy, but it's fun to think about. That's all for now. Thanks for watching, bye.